So now we're looking at another truss. So we see four external loads on it, all going down on joint B, C, D, and E. And then we see the main connections. There's a main connection at A, which is a pin, and the main connection at F is a roller. So what was the thing that we do with trusses? The first step we do is we always remove the structure from its main support. So I'm going to do that. I'm just going to erase them right here. I'm removing it from its main supports, and that's still A. And we saw that it was a pin. So for pin, I have to put a force in the Y and a force in the X. And then we also have at F a roller. So at F, I have a normal force. So in the first step, you take the structure, remove it from its main supports, and find what those values are. So we have three unknowns, we need three equations, we have one body, one structure. What forces do we, which equation do we want to do first? How about some of the forces in the X? Because I'm seeing that some of the forces in the X, the only force in the X is AX, so AX is equal to 0. I don't want to do the sum of the forces in the Y because there are two unknowns, so I'll do some of the moments about A. So I have 1,000 times 6, I have 2,000 times 12, negative, negative. Negative 2,000 times 18 minus 1,000 times 24, and plus I have n times 18 equals 0. And what does n turn out to be? Let's see. I have 5,000.
Yep.
And then we do sum of the forces in the Y, which is AY plus N is equal to 0. So AY plus W minus 1,000 minus 2,000 minus 2,000 minus 1,000 equals 0. So if n equals 5, AY must be, is it 1,000?
Mm-hmm.
1,000 pounds. Okay, could I do a check? If I ever have extra time, I should always do a check. Do a sum of the moments about some other point to make sure that your values check out. That's what's really great about statics. You have the opportunity to do checks before you move on. So now we know that n is equal to 5,000 pounds, and we know that AX is equal to 0, and we know AY is equal to 1,000 pounds. So I'm going to erase my calculations here. So I didn't tell you what the question was for this problem. And what the question is, they want to know find the loads in members CD, CF, FG, and CG. Now, how do we know that this is a truss again? It's because it's all two force members. How many members are here total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13 members total. If we did method of joints, we would have to find all the members. We would have to look at all the different joints to find the members. Now, to back up to something that we did last class where we learned there are two rules on determining which forces are zero force members. Do you remember what those two rules were? One, if you have a joint where two members come in parallel to each other, they're collinear rather, and one is non-collinear, if there are no external supports or loads at that point, then the member that's not collinear is a zero force member, which means it holds no load. Can you see a joint here that follows that rule? A joint where three members come in, two of them are collinear, one's not collinear, and at that joint there is no external support or no external load. Don't you notice that G fits that description? This is a joint where two members come in that are collinear, one's not collinear, there's no external support or load here, so this guy is a zero force member. So we already know that CG is equal to 0. Okay. The other rule on zero force members is where we had two members come in and there was no external support or a load, and that A doesn't pertain to it, and the only other possible one that could pertain to it is E, but E has an external load too. So it's only CG that's equal to 0. So now what we're stuck with in terms of the problem is finding out these guys. So let's figure out where they are. CD is right here. Oh, let me use a different color. CD is right here, CF is right here, and FG is right here. So if we want, we can do method of joints. If you wanted to do method of joints, would you start from the left or would you start from the right in terms of where these members are? I would start from the right because it's less, right? If you do C, you have to find these two. Then you move to B, you find these two. Then you move to H, you find these two. And you got to keep going on. I'd much rather do less work. So at E, I find these two. Then I go to D, find these two. Go to F, find these two, and then I found them. But it's 1, 2, 3 joints that I have to analyze. And I'd rather not do all that. I'd rather do something different. Remember the idea that whenever we break something, the internal force becomes an external force. If the member stays intact, then that force is internal and we can't analyze it. So if I want to find out what CD is, what CF is, and what FG is, why not just break the truss right in half here? I have a left side truss and I have a right side truss. And if I analyze the right side now, let's see how you would draw it. Here's D, here's E, here's F, here's DF, and this goes to point C, this goes to point G, and this goes to point C. So what forces do I have here now? I have my normal, which was 5,000 pounds. I have my 1,000 pound, and I have my 2,000 pound, and then I have my CD, I have my CF, and I have my FG. Does that make sense? Rather than analyzing joint E, then joint D, then joint F, 3 different steps, I'd rather just break the structure in half at the points where I'm trying to find the members and just analyze the whole right section. Why am I choosing the right section, not the left? It doesn't matter. I could do either one because it's in static equilibrium, right? So the whole right section is going to be equal and opposite to the loading on the left section, no matter where I broke it. But on the left section, I might have more stuff to do. So I just picked the right side. So now we're looking at a piece of the truss, and we have our 1,200 external. We have our load at F, and then we have these 3 unknowns. If we have 3 unknowns, how many equations do I need? 3 unknowns, I need 3 equations, and we have to decide what kind of what equations to do. Do you want to do sum of the forces in the X? No, because there would be 2 unknowns. How about sum of the forces in the Y? I think that would be a pretty good one. Do sum of the forces in the y equals negative 2,000 minus 1,000 plus 5,000 plus, oh, we gotta put the distances, don't we? This is 6 feet. This right here is 8 feet. And this dimension right here, if it's 6 in the x and 8 in the y, isn't it a 3 in the x, 4, 3, 4, 5? So going back to some of the forces, 2,000's down, 1,000's down, 5,000's up, and then 4/5 of CF is equal to 0, and CF turns out to be, what does it turn out to be?
2,500, I think.
Okay, let's see. What'd you get? 2,500?
2,500.
Okay. And I got a negative.
Negative, yeah.
Negative 2,500. Before we move on, let's go back and say, is a negative, what does that tell us? It's compression.
I need to start a new segment.
Okay.